In this video I'm going to have a look at the OlympicDestroyer malware. And to be specific, I want to do a static analysis of the wiper component of the malware and just give you a rundown of how the wiper actually works. If you're interested in a dynamic analysis of this, you can check out the YouTube channel of Colin Hardy. The channel is of the same name, and he has an excellent video online of the dynamic analysis. Good, so now I'm in Ghidra and I'm just going to do a quick import. I didn't need any other special options for this executable. It's recognized as a Windows 32-bit little Indian executable right away. So I just continued on from here. Now for the analysis options that will pop up in a second, I didn't choose anything special. I just went with the defaults, and in a moment I'm going to show you the main as soon as the analysis down here is actually done. So here you can already see the magic MZ, and now that the analysis is done, I'm going to change over to the symbol tree, and here under the functions you can see this entry. Now in the case of this wiper executable, the main is actually pretty easy to find. Now the security init cookie is just some standard Windows stuff, as well as this get startup info, and if you just come down here you can see this function right here, and this is actually going to be the main. So I'm just going to rename that real quick and we will jump in here. So now that we're in the main, if you take a look around, there is actually not a lot of code in here, and the first thing that I noticed was that this function is called multiple times, each time with some strings as a parameter, which are all just commands. So because of that, I decided to jump in here first. Now, just one side note here, you can actually extract these strings with the strings command. That's available for Linux and Windows, and I will explain what each of these mean. But if you already know, you can just from the strings actually find out a lot about what this executable does. Now let's go in here, and you can see this parameter 1, we can just rename that to command string, because that is what we saw in the main. And here a copy of command string is made. So I'm just gonna make this underscore command string, and if we go further, we can see this create process W function and this WS_printf up here, and they both use the same variable, the same buffer as you can see up here. And if we look into MSDN, we can just take this function signature and just add it in here to create process and find out what this does. So here you can see this parameter is actually this LP command line. I'm just going to look up what this does real quick. Now this is just the command line string to be executed, so I'm just going to rename this to this LP command line, and then it's nicer to read. After looking around a little bit, I found out that these values right here are part of the process information struct in the Windows API. I just have a copy of the struct here, and you can just look this up in MSDN as well. Then these parameters make sense, and I will just rename this right here to proc info struct, and I think that's a pretty good name and another way to make this more readable. Now this next function, Getsystemdirectory, just stores the path to the system directory here in this variable, and I'm just going to rename it real quick. Now this WS_printf might look a little bit confusing, because here you can see 3 string formatters, but only this string right here. Now If you dig into the disassembly or the listing view right here, you can see that this command string is actually pushed. So this right here contains the command that was passed to the function. Now in the next step, the create process function is used with this command line string and this process info struct right here to create a process. This variable here just checks for success. So I'm just going to name it success create process. And if this returns a value that is not 0, a little typo here, then we come down here. So now when the process creation succeeds, we end up down here in this if, and this wait for single object pretty much waits a very long time. This second parameter is a value in milliseconds, a wait time. You can also look this up if you don't know in the MSDN. Now here, when this time runs out, the handles are closed. So that's pretty much it for this function. I am just gonna rename it to exec command. I think this little walkthrough has shown pretty nicely what all of these functions right here do. So now we can continue on. So back in the main, this lookup privilege value. This function just looks up this name and which LUID represents it. And this right here is the LUID. So I'm just going to rename this. And in the next part, this looks like a struct is put together. Now, this comes into play a little bit later in this adjust token privileges, as you can see here. So just by checking this out in MSDN, it's actually pretty easy to find out what this value is and then just annotate it. So I'm just going to go back here and put this in as a comment. And here you can see this token privileges new state, and that's this right here. So I'm just going to call this new state real quick, and then this here stores a token handle. So I will rename this to token handle. And now it becomes a little bit clearer what's going on here. So to summarize all of this, first of all, this getCurrentProcess function gets a process handle. This is used to get this token for the current process, and this number right here, I looked it up, it contains the 0x20, which is the specifier to adjust privileges. Now, this new state was put together up here with this shutdown privilege, and now using the token handle, this new state, so these shutdown privileges are actually initialized right here. So this means here the malware just gets itself the privilege to shut down the computer. Next is this innocent function right here, which doesn't really have a name at the moment, but if we jump in, we can see there's a lot going on. So this is the part that will actually shut down services one by one. And I will walk through this just as before. Here you can see my annotated version of this function. I renamed it Disable Services. And if we look at this OpenSC Manager, we can see that this just obtains a handle to the service control manager of the machine. Coming down here, this enumerate services status is actually called twice. This might seem strange at first, but after a little bit of research, one can see that this LP services parameter here is actually 0. Also, the buffer size is 0. This is a buffer that contains the information about currently running services, and this remaining bytes is is actually gets a value that tells you how large this buffer has to be. And if you already pass a buffer in, it gives you the remaining bytes. Now the buffer here is 0, so the remaining bytes in that case will be the size of the buffer needed. And this is actually just done here. And then a heap allocation takes place, and the LP services is allocated in that way, so it can hold all of the service information of the currently running services. Next, the success is just checked right here, and if there are some services currently running, we just come into this loop. Now in this loop, a handle to the current service that the loop is looking at is obtained. Now services are looped by using a pointer to the services in the buffer that we got from this enum services status, and it goes through each service. Now once the service is opened, this function is called with the same trick as above, just to get the size necessary for a buffer to just accommodate the service configuration of the current service that is being looked at. Once this is obtained, some heap memory is allocated, and then the service configuration for this service is changed. And is actually changed in a way that all zeros are written in here, and for this start type of the service, this 4 is written, and this just stands for service disabled. So looking at this, one can say that this disables all the services on the system, and of course it frees the heap memory so nothing crashes and attracts suspicion. So going back to the main, we can now talk about this function right here and the function down here, and of course the thread. So back at the main, there was this WOW64 disable something something, and here there's actually a example in MSDN that explains what this does. So first of all, this function disables the file system redirection for the calling thread. File system redirection is enabled by default. And if you look at the example, you can see that this redirection disabling allows that a 32-bit application that is running under this WOW64 can open the 64-bit version of Notepad in this case, and this just is located in the system root. So that's what this actually does. This WOW64 is a subsystem that is included in 64-bit versions of Windows that allows 32-bit applications to run under 64-bit. So now we know what this function does. It actually just disables this file system redirection and saves the old value here. I already annotated this, and then the configuration of the redirection is restored down here. So these commands were still open. Now this deletes all shadow copies on the system. Those are backup copies or snapshots of computer files. I always like to just annotate some definition from Microsoft in here. This delete catalog deletes the backup catalog, and here you can see the string which is a little bit longer. Essentially this disables the recovery screen due to shutdown failures and the automatic repair. And the CL deletes system logs and security logs. One last thing I want to get back to is in this exec command. Now this string here, where the command that is passed to create process is assembled, left a couple of things open, or there were a couple of open questions. Well, the first one that I was able to answer in the decompiler view is that this string, this cmd.exe, goes to this first string formatter. Then I said the command is put here, and I could find that out with the disassembly. Now the second parameter was open. There was also something going on up here, which if you jump in here, well, I didn't actually want to reverse this, but I wanted to make sure that this string is what I thought it was. And also I couldn't account for the sysdir. So I went ahead and did a dynamic analysis. And here you can see what is actually assembled in, in this buffer here, in the case of shadow copy. And here is the system path and an executable that is used for administration. Now this is used for the shadow copy deletion. For the catalog deletion, a different executable would be here. But combining the static analysis here with the dynamic analysis, I was able to make sure that this actually does what was expected. Okay, so now I'm back at the main. The sleep here sleeps for this millisecond value, and if you convert this, you find out that this is an hour. And after this is done, the system shutdown is initiated. The only thing that is left at the moment is this thread function that is spawned here. But due to the extent of this function, I will actually omit this for now and do a separate video on this. So I think this little dive into the Viper component of OlympicDestroyer was actually quite interesting, and I want to end with a citation from Cisco Talos. They said in their blog that wiping all available methods of recovery shows this attacker had no intention of leaving the machine usable, and this just shows that the goal of this malware was destruction. And with that, I will sign off now. So thank you for watching, and goodbye.